I'm very pleased to have the opportunity to talk to Professor Neville Plint, the Director of the Sustainable Minerals Institute at the University of Queensland in Australia, a position he's held for 5 years. Neville's original background is in chemistry, followed by a PhD and an MBA from the University of Witwatersrand in Johannesburg. And he has a deep understanding of the mining sector, having worked for 20 years with Anglo-American in South Africa. He is, as many of you know, a globally respected leader, and in his career, he has focused on working with people to improve operational performance across mine sites, in particular through implementing new technologies. He also understands the leader's view from within mining, having been involved in a lot of improvement projects and cost-saving initiatives that drive business value. And he has an extensive global network across research professionals, mining companies and research organisations. So I'm particularly pleased to speak to such an inspirational leader today. Welcome, Neville.
Thank you. Thank you.
Let's talk first about the CEEC Medal win. What does a CEEC Medal win mean to you, and why is this type of award important for industry?
So the CEEC Medal award is really important because it communicates and it shares information about work that's been done. So often the industry is portrayed as being not very innovative, not very collaborative, and that's absolute nonsense. I think it's just simply not true. The mining sector is incredibly innovative and it collaborates, but often we don't communicate it particularly well. And I think what the CEEC Medal does is it gives us an opportunity to communicate research work that's been done, and particularly the medal that Grant got today was research work that he had done at the JKMRC, and we can now communicate that research to a wider audience. But I suppose what's more important is that research has been taken up by the sector, taken up by the industry, so we can show impact from the research. That's absolutely critical, really, really important. And it gives us an opportunity to celebrate that. So it's to celebrate great work, we can communicate it, and we can collaborate, we can connect with the sector. So for me, that's why the CEEC Medal is so important, and also really important to be here because of a long-standing relationship with Grant and his connectivity with the university.
Fantastic, thank you. Neville, Grant Valentine developed his novel concept when he was at the UQ Sustainable Minerals Institute's JK Mineral Research Centre. Tell us a little bit about where Grant's winning work fits within the overall Institute's research program and priorities.
So the work that Grant's been doing is part of a broader program of work within the JKMRC looking at energy efficiency. And that really touches on the two core areas that the SMI focuses on. So the one is productivity and the other one is sustainability. So you can see how energy touches on both of those. It's around how do we use that energy as efficiently as possible in the production space, low footprint, but then also what is that impact on global sustainability? So the more we can reduce that energy footprint, the greater the positive impact will be on global sustainability. So I suppose it also then just steps back into what the Institute's all about. And we spent a bit of time thinking through our core purpose, and that's to inspire and to enable the supply of the resources needed to address these global sustainability challenges. And I suppose what we need to be really focusing on is the yield of metal, which we've done for many years, but then also what is the associated footprint, and that's around energy, water, and waste. So it's incredibly exciting for us as researchers to see this work being taken up and being adopted by the industry, and the industry actually getting benefit from it. So I suppose if we step through the Institute, that's really what we want to be able to do. And then we step further down into the JK. It's really focused work, and Grant's work has really been focused on a part of that value chain comminution, and having a look at what the energy consumption is, and also largely because it's an incredibly inefficient process. So if we can make small changes there, we can make a large change in the overall energy usage. And the current paper that Grant put through is actually even more exciting because it looks at the entire circuit. It looks at all the peripheral users of energy to deliver a product out of a comminution circuit. So I think the energy curve innovation is a brilliant way to benchmark across the sector and probably across different clusters within the sector and it gives the end user an opportunity to understand where they sit on the energy efficiency curve. And it gives them an opportunity to say, well, hang on, I'm pretty low, pretty high, where do I fit? How can I improve? And once you've got a benchmark, you know you can do better because somebody else has done. And then finally, I suppose the work has been instrumental in informing and positioning our further research strategies. And those are really around understanding the fundamentals of breakage. And then by understanding that, what can we do to make novel devices that break rock selectively? And to do that in the most energy efficient way. And finally, just to look at how do we redesign the whole process, that whole value chain, such that we minimize that energy footprint. So productivity, sustainability, in the sustainability space, how do we get into eco-efficient comminution? What can we do differently?
Thank you.
Grant's work is then focused in the next level and really looking at, so in that value chain, where do we use the most energy? And arguably it's comminution. And how efficiently do we use that energy? And that's a great question to ask. And I think a lot of people have published work on how efficient the breakage process is, and the numbers are staggeringly low. So the question is then, if we are very low in that space, how do we improve it? But also, how do we compare across the industry? Now, that's where the CEEC work is just brilliant. So we suddenly start to bring the sector together where we can benchmark against each other, and we can start to have a look at, so this is the benchmark of what a really efficient operation looks like. What are they doing? So what can we learn from success? And then based on that, now we can start to shift the whole industry. And I think it's been really exciting to see companies engaging with this work and having a look at it and saying, gee, that's where we fit. Wow, we've got room for improvement. And we better have a look at this and work out what's happening. So absolutely fantastic piece of work. And it's amazing how when the industry starts to engage with a piece of research work like this, we suddenly start to get what the research questions are. And that then leads the next generation of PhDs. So we suddenly have a look at it and go, well, so why is that circuit more efficient? What are the breakage mechanisms? Do we understand them? Based on those breakage mechanisms, so what could we design differently? Different machines? Could we improve the machine? Could we improve what we feed to the machine? So absolutely, fantastic piece of work. The spin-offs are just brilliant. So where does it fit? It's pretty much central to what we do. How do we bring about change? How do we improve things?
Yeah, so if you make things more efficient, more productive, and more sustainable, that's a win-win for the mining leaders to invest in those changes, to share best practice, to benchmark, and then to implement that change faster through collaboration. Okay. Now, I'd now like to turn to leading change and ESG. We've seen much talk about environmental and social governance, or ESG, including many governments and companies committing to net zero by 2030, 2050 or 2060. This is a challenging time, but also an exciting time of change. What do you see as the key factors for success in industry's progressive uptake of eco-efficient processing to really strive to meet some of these ESG goals?
So I suppose what I'd like to do is almost start at the back end of the question and just think through, so what are those sort of key drivers that are creating the change that we see? And as you go through it, there's some really obvious ones, but the one that really is fascinating me at the moment is just having a look at the rate of change. So a lot of our models and a lot of our thinking is based on a linear improvement. So our budgets, so budget plus CPI. So we put in place an expectation that the change is going to be linear. We then have a look at all the changes that are happening, and none of them are linear. They're all exponential. So suddenly now we're battling to deal with this rate of change. So some of those changes, which I think are already coming through at pace, is we are seeing societal expectations changing. What's the root cause of that? Well, we can step through that and go, well, digital connectivity. So digital has so many benefits for the industry, it has so many benefits for humanity, but what it does do is enable this connectivity. This drives faster change. And it creates greater society expectations. So what does that mean? It basically then steps into, well, what we see now is huge realization of the effects of a increasing population, an increasing use, an exponential increase of carbon fuels, and what that's doing to the climate, to the environment. So we're suddenly starting to see massive amounts of data showing the impact of climate change. So you put all that together, and it's the rate that's really what's causing the challenges for the sector is, so how do you respond? So how do you respond to exponential growth in population, exponential energy consumption, exponential fuel consumption, CO2 production, loss of biodiversity, waste production? I think that's caught the industry a bit by surprise. It's just how much waste is produced to meet the demand, the metal demand. Decreasing head grades, increasing demand, the amount of waste that's produced is exponential. Soil contamination. We see degradation of freshwater resources, and all of this is happening at pace. So it's no surprise then that suddenly countries and companies are saying, we have to stop this. We can't continue on this exponential increase in these environmental impacts. So you get the commitment to net zero by 2050. So that's pretty exciting if you're looking at driving efficiencies, because suddenly now you have a large external driver, a momentum that starts to drive you towards the change. And no longer can the 5% improvement be acceptable. You have to achieve a massive step change. So I think where the industry is at the moment is it's got a unique opportunity. These things happen every now and then in time where a particular sector has an opportunity to have a massive positive impact. And that's what excites me about the sector. So if we are going to achieve those carbon goals, those targets, those zero emission targets by 2030, 2050, the amount of metal that has to be produced is 2, 4 exponential amount more. So how are we going to do that? And society is saying, yes, we'd like you to do that, but you have to do it with a net zero carbon footprint. And we're going to hold you accountable for that. So, I mean, in terms of engineering, if you're in the technology space, this has to be hugely exciting because there's such a driver and such momentum to make that happen. I think the challenge is that society is going to be saying, I'm going to hold you to account. So not only do you need to demonstrate that you can supply, but you need to have responsible supply chains. You need to have zero harm to the communities and the environment. So exciting times for engineers. If you can get your head around being able to design for societal's expectations. So just to wrap up that, I suppose there was a bit in the question where you said, so what do I see as being key success factors? And when you've got this massive amount of changing environment external, you really need to think about, so what can buffer you against that? And I think for me, the success factors is really going to be around the attraction and development of people. So how do we make sure that we have the best people working on these big problems and developing these technologies? How do we make the sector really exciting and interesting? And people feel that by being part of the sector, they can make a positive contribution. So that's attracting development. And then the one that's always close to my heart is, how do we do rapid implementation? So we just don't have the time. 2030 is not far away. We don't have the time to do a 20 or 30-year project. So we have to turn this around really fast. We have to implement it. The only way we're going to do that is in partnerships. So success factor, how do we co-create? How do we work together? How do we deliver together? Because we don't have time to try and backwards and forwards through piloting stages and etc. We're going to have to take some risks, and we're going to just have to trust each other. We're going to have to work really hard to do this.
Yep, take some risks, be the change you want to see in the world, really. People with great ideas really need to step up and be willing to help from inside or outside of the industry.
Absolutely.
Yeah,
Absolutely.
Great. Okay, I'm going to talk about innovation now, Neville. It's clearly really important to industry, particularly if we're going to rapidly find solutions and meet some of these goals that are being asked from us by our investors and shareholders and stakeholders and communities. What advice can you give professionals in industry and researchers around the world to support the most senior mining leaders to invest in good changes?
So I think spend a bit of time thinking about this, and it's I suppose if I could get all my engineers to start defining the problem from the external perspective. So I learned this from one of my previous managers, who I went in for a meeting with him, and we were having a long chat, and he popped off his shoes and he said, "Here we go, Nick, go and put on my shoes." And it was a very simple message. It was, have a look at the problem from my perspective, and then think about how you would respond and what you'd be asking for. And I think we've got to get much better at that. So how do we step into the community's shoes and understand their expectations, understand their challenges, understand their lives, and then with that insight, start to engage in a respectful conversation of what we can bring to improve their lives and to meet their expectations. Often what I'll see is we find an ore body, we design a fantastic plant, we put it all together, and then we go and tell everybody how fantastic it's going to be and how good it's going to be for them. And pretty surprised when they turn around and say, well, actually, we probably didn't want that. No, I'd rather you didn't put it there because there's something really important to me in that space. So I know a lot of companies spend a lot of time in the community engagement space, and I think the industry does it. Generally, it tries to do it really well. I think we need to invest more in that. So I suppose it's that articulation of what you're wanting to do and really just looking at it from the other perspective. Would save us a lot of hard work and a lot of time if we actually could just spend more time on the front end, before you get into the project, rather than trying to bolt things on at the end. And that would go for tailings management as well. Design it so that your process produces a residue that is useful or you can manage appropriately. Often it's the back end of the design. We've seen that change fundamentally now because of the recent events. So what are expectations and what can we deliver for them? What meets their expectations? Will this project impact on the environment? Yes. What will that impact be? How will we manage it? And I suppose the other one which I found really interesting, and we did the welcome to country and the acknowledgement of traditional leaders this morning. And every time I say that, it reminds me that I'm a guest.
Yes.
I'm a guest in somebody else's land, and I need to treat it with absolute respect. And also, I'm a custodian for future generations. So when making decisions, how well informed is that in my decision making? Now, this is a mile away from the work that Grant did in looking at energy efficiency on a particular piece of equipment, but I think it all informs that. You may well put in a process that isn't the most efficient process, but it fulfills a requirement. You may actually mine much slower, which is not the economic optimal, but because it fulfills the requirements of the region, of the communities, and maybe gives them a longer term asset that they can benefit from. So I think that would be the other one, I suppose, which is interesting, is I hear a lot of people saying you need to fail fast and you need to learn from failure. And gee, that's a tough way of learning. That really hurts. So wouldn't it be a lot more interesting to learn from people's success and actually having a look at what worked? And back to the first question. So how do we celebrate that success? If somebody else is successful, it doesn't mean that I'm not successful. And yet we don't celebrate it enough. So learn from success, what worked, problem definition. Think about it from everybody else's perspective.
Listen. Neville, I'm just going to talk now about leading change and SMI's role. SMI is a leader in innovative thinking. Tell us a little bit about your organisation's contributions to really breakthrough ideas, things that could really change eco-efficient comminution and processing in particular.
Okay, so I'm going to really just focus in on the contribution from the JKMRC.
Okay.
In terms of the institute, we we sort of covered that up. We have a broad focus on social, environment, health and safety, as well as productivity issues. So the broad sustainability. And our strategy has been how we bring all of that skill set together to tackle global problems. And then within those global problems, I mean, the one would be the supply of metals. We'd look at mine life cycle. We look at governance and leadership. We look at digital, and as well as transformational learning. So we've got those programs running, and that's really to connect us across the university and into our international partners. And that's really our programs where we're looking for global impact and global innovation. Now, within those programs and within the centres, we'll do some really specific work to unlock particular problems. So in the comminution space, of course, we're having a look at the fundamentals of breakage. So if we can understand breakage really well, we can then design to enhance that breakage. And really what we're wanting to get out of that breakage is very selective. So ideally, we'd want to only break rock that has material in it. And then the material that doesn't, we want to be able to reject it. Or we'd want to be able to break it and break the value material into particular size fractions. So suddenly we're starting to move from a brute force of let's just smash everything and then hope like mad we can get it fine enough and liberated enough to recover, to so how do we be very selective? And how do we be very targeted in what we break? Now that's a very different approach to how you would generally normally think about a big comminution device. So that's really driven our research, is how do we characterize rocks? How do we understand how they break? How do we model the breakage? And then ideally from all of that, we can look at how do we improve the devices that do the breakage. And then of course you wrap that around with how do you improve the material coming into the breakage devices and how do you improve the separation past that. So those would be the areas that we work in. The ones that are particularly interesting at the moment is there's been a huge amount of work around high voltage pulse breakage. And we've managed to unlock a little piece of that technology where we can be quite specific of how much energy we put in and just enough energy to target breakage of rocks with material. So suddenly this starts to unlock a lot of the upgrading potential through simple devices like screens, through sorting machines, et cetera, et cetera. So it's a really targeted technology, great opportunity. Coupled to that, of course, if we move downstream, there's a huge amount of work going on now. So you've liberated it as coarse as possible. How do you separate that out? And that's the coarse particle flotation work, where we're looking at not having to fully liberate something to be able to recover it. And therefore, we can recover material at a very coarse size fraction and put a lot of material into a small size fraction. And suddenly you start to have huge impacts on your downstream tailings, water recovery, energy. So you start to clip these pieces of technology together into a value chain, and you see a massive improvement. And then, of course, what you definitely want to do is have the digital technology running with it to give you a very optimized, stable process, because you all know a stable process more efficient, and you can then optimize further. So that's the work that we take in the models that we've developed over the last 50 years and build them into what we call model predictive control and putting them into dynamic control systems so that we can manage the entire value chain and optimize it real time. So I think the buzzword is digital twin. So that's really what we're looking at. Good selective breakage, selective separation, good water recovery, optimized circuits. And we're doing research in those areas and bringing that all together into a package.
Okay, now I'm going to turn to partnering and industry within the context of leading change. How important do you feel research institutes are, and how important is that partnering and long-term support with industry to really bring those new ideas and thinking to success, to really advance those creative ideas, those new ways of thinking through the technology readiness levels so that they can be applied by industry?
So I think partnering is key to any research institute. So particularly for us, if we don't have the support of the industry for the work that we're doing, we actually don't have a mandate to exist. So in the JKMRC and the BRC and the productivity space, we are absolutely critical that we have the partnerships from the sector to do the work that we do. And the longer term that is, the more ambitious we can be in tackling these fundamental problems that we know we have to solve in the long term. So I suppose what we'd like to be is in a partnership where we work together, and I like the term co-develop. So So often the industry will know what the problem is, they're experiencing it. What's useful for us is to get an understanding of that and then have a look at, so what could we do to tackle that problem? Research that's not connected into that ecosystem is very, very useful. Make no mistake, curiosity-led research is absolutely critical, but that's not the space that we work in. So therefore, we're very, very tied to these partnerships. And the longer-term partnerships, I think, have added value. Now, they add value in a number of ways. One is that we have a corporate memory of the issues. Two, we're able to develop people that the industry then can use and they can attract. And it builds excitement about the industry. And I think we often miss that. So there's nothing as exciting as talking to a PhD student about their research. If you want to inspire people, just put somebody who's really excited about their research and send them to schools. That you're going to change the narrative around what mining can deliver and what it can do. So I think there's so many benefits of building those long-term partnerships, and we're really appreciative of the partnership that we have. We can see what it does, and often people will dip in and dip out, but the long-term partnerships are the ones that really endure and create that legacy where we start to actually produce something that's beyond our time and our custodianship of an organisation.
Turning to CEEC now, we're really fortunate that the SMI has been a long-term collaborator with CEEC. What do you think are the most important roles that you feel CEEC plays?
So it's really important to have an organisation, and there are a couple of them around, but an organisation where the industry can come together and they can have an independent convening power that can bring them together around issues and enable those conversations and those sharings of learning. So I spoke about learning from success. So how do you do that? So CEEC has got a really important role to play in being able to build a trusting environment where companies and individuals can come and share. And they can share openly and we can learn from each other. Really, really important role. The other role is being able to listen to those voices and work out, so what are we going to do about this? All right, so let's all get together and do something. What is that problem definition? And then the final one, of course, is the relationship with the research providers and being able to sit with the research providers and say, look, this is what we think the problem is. How would you tackle it? What would you do? And it's building that respectful partnership and having a facilitator, I think is just fantastic. So huge, huge supporter of CEEC, have been in all my roles because it has a focus and it has an ability to attract people to have conversations around that focus. Really, really critical role.
Thank you. Turning to the future now, on innovation, where do you think mineral processing is heading towards in the future?
So I mean, I suppose this one is for my mining friends because they want to get rid of mineral processing as quickly as possible. I think we're going to be around for a while as mineral processors. But so I always like to think, so what's going to happen in the near term? So 0 to 5 years, I think what we're going to see is the digital automation drive is gaining momentum and it's going to get more and more sophisticated, and that's going really fast. So we'll see the connectivity across value chains, we'll see that optimization. I think we'll see a fantastic productivity improvement. Challenge is everybody's going to get it, and if you're not, you're going to be actually falling backwards. So you may not see a massive productivity gain because the whole sector is going to pick up. So you should see it in your energy numbers and that. So I think that's where we'll see initially now is automation. I think what we'll see after that is where suddenly, so what has automation enabled? And I mean, there's so many ideas out there. So suddenly now you can move to miniaturization or smaller pieces of equipment that are connected, that understand what each other is doing automatically in real time. And you start to now build technologies that are enabled through automation and digital. I think what we'll see, just stepping backwards a little bit, we'll see a good drive towards more selective processes. So the baseline will stay the same, but we'll start to fiddle with chemistry and we'll start to see better selectivity maybe in mineral processing. We'll see a bit of selectivity in breakage coming through. We'll see a lot more optimization of the value chain. And there's another, 20 to 30% uplift where you can blast and get a benefit. And we've seen that work coming through from CEEC ore and I think Hatch is picking up on that great engineering, fantastic. You're going to see big efficiency gains from that. So that's an implementation. And then the next one is, so what does automation enable? And then I think the longer term one has got to be having a look at biological systems. And we're seeing in other sectors that research in biomimicry and the biological research is moving ahead really fast. And I don't think one should underestimate the leaps and advances that have been made because of COVID. So suddenly now there's technologies, there's capability there that really does supercharge that biotechnology space. So I would be expecting to see in situ processes coming through. And they may not be the traditional in situ leaching. They may well be these nanobots or whatever else, the science fiction people work. I think we're going to see that. And I think we're going to start to see more biomimicry coming through. And how does biological systems do this? And it'll need to be in situ. So we'll go to zero footprint. We're going to have to think about only extracting what we need to be able to supply into those technologies.
Transformation. Okay. We've talked a bit about collaboration across the global industry. What future ideas would you really like to see industry tackled together on shared industry challenges? For example, reducing energy emissions, water and tailings.
So I think the focus on energy was really critical, and I think that was the right focus. But it's very difficult to talk about energy without water. And I think the next piece of work in terms of benchmarking is going to be having a look at water efficiency. Now, a lot of work has been done in that space, and ICMM have a standard that came out of Chris Moran's work at SMI on looking at how do we build those water models and water management. But that's got to be the next phase of particularly the CEEC work, is how do we start to couple that? Do we move to very, very dry processing? What are the impact of recycles, etc.? So there's a number of questions there that we need to have a look at. Coarse particle flotation is going to unlock those questions quicker. And of course, the dealing with large amounts of tailings material is also going to accelerate the question mark around what do we do with that. And we've seen that in a number of the different technology challenges that are out there. What do we do with all the material that we mine that potentially has no value? How do we generate value from that? And I think the numbers that are coming out of our complex ore bodies program, the amount of tailings that will be produced in the next 20, 30 years is just astronomical. It's just not sustainable. There's just no ways society is going to allow that to happen. So we're really going to have to think about tailings. And I think that's why it's getting so much attention at the moment, not only because of the catastrophic failures, but because of the potential of what it means to the industry. So I think tailings is a big one that we're going to have to, as an industry, come to grips with. And it's much like there's nobody that should be competing on health and safety. And I think we're going to end up in a space where we're not going to compete on environmental. We've got to share that technology, water treatment technology, rehabilitation technologies. How do we do closure responsibly? Because if we don't do it properly, we're not going to be able to open new mines. So we're not going to open new mines, and we're not going to be able to produce the metal. It just becomes a vicious cycle. We have to deal with those legacy issues, and the industry has to come together on that.
Yep. So less working in silos, much more working together, so that everybody lifts the standard and accelerates the reduction of the footprint and the solutions.
Absolutely.
Yeah. Great. Okay. So overall, what's your vision, Neville? What changes would you really like to see industries strive for, say, in the next 3 years or by 2030?
So I think, and once again, it isn't in the production space is where I see the most important changes that the industry is needing to make. And the industry is making those changes, and it's articulating a very different future to maybe what was articulated 10, 20 years ago. And that articulation is that the sector is here to improve people's lives. And if you go through all the companies, their purpose statement is really around improving people's lives. And that sets a very high benchmark in terms of the behavior of everyone in the sector. So we are probably measured by the lowest common denominator, not the highest common denominator. So being able to think through, so what are the standards in place? What would we consider to be acceptable principles? So the ICMM has put out a note there saying, this is what we think is acceptable. Now, how do we hold people accountable to that? So from my perspective, the area where a large investment is needed is in the social sciences and the social performance space, where the sector really needs to grapple with some of the really difficult challenges associated with the sustainability goals, associated with human rights. So how does the industry stack up against the basic human rights? How do you have a project in an area where there's poor governance? How do you deal with that? So I think that's where I think the next 3 years is going to really tax the industry, is thinking through those issues to ensure that their social performance meets their aspiration. Because any disconnect there in the digital world becomes exaggerated. Now, beneath all of that, of course, as engineers, what do we have to do? Well, we have to deliver those outputs. We've got to get to zero carbon. We've got to produce X amount more. And we have to do it in an economic way. And all of that's going to require technology. And it's going to require incredibly, incredibly bright people getting together and really thinking about this. Maybe we need a different business model for mining. So the work that happens in the next 3 years, I think, will position where the industry goes after that, and how it repositions itself.
Thank you. Well, I'm going to wrap up here. Thank you so much, Neville.
Thank you.
Really appreciate your insights, and let's see where the industry goes in the near future and how far we can get.
Fantastic.